All right, question number 26 is another probability question. Let's say that you have a pair of dice that you roll at the same time. Often that happens in games, right? What is the probability that you roll a 1 on both dice? That's something that we usually refer to as snake eyes. So whenever you have probability of more than one thing happening, the problem gets a little bit more complicated. This is an example of what we call compound events. And it's something that we'll study a little bit in geometry this year. Now, when you looked at it back here in middle school, though, you probably didn't look at it in the context of compound events. Instead, it was, hey, let's just try to count up the number of ways that this thing can happen. Okay, so probability, remember that we write this thing as a ratio, and we want desired outcomes up top, we count them all up, and then we divide it by the total number of outcomes. So if you could just list them out, it'd be pretty easy to write that as a fraction. So let's start that. Let's say that I have myself a pair of dice like this. I got a red one and I got a blue one. I made two different colors that you're going to see why in just a second. Okay, so I would suggest if you're going to make a list to do this question, that you be as organized about this as possible. So let's say that I roll the number 1 over here, and then I roll the number 1 on the blue die. Okay, so this is what I want to happen. This is the snake eyes event. And that's the only way that you can get snake eyes. A 1 on the red one and a 1 on the blue one. So when we're talking about the probability, that's the thing that's going to go up top. It's the number 1. The more challenging part of this is the total number of outcomes. How many different ways could I roll these dice together? And a lot of people mistake this as, well, the way that I would do this is I can do 6 different things over here, and I can do 6 different things over here, and I add those 2 things together, and I get 12. But 12 is wrong. That is the incorrect answer. Instead, let's see how we could approach it. We could, like I said, make some sort of organized list. I already had the 1 and the 1, so let's keep the number 1 over here on the red die and kind of pair it up with everything that we could have over here on the blue die. And so the blue die could also have the number 2. And I could go with the number 1 on red and the number 3, and then so on. Some people do this like this. I have the number 1 on the red die, and then you just go, that can be paired up with the number 1, 2, 3. I think it's called like a tree diagram or something like this. 4, 5, and 6, right? And you can count up all those different ways. Okay, and then once you have gone through all of the number 1s on the red die, then you switch to the number 2. So you go 2, and then over here you have the number 1. And then you might be going, yeah, but I already listed that one. I listed that one right up here. But did you really? And the answer to that question is no. That's the whole entire reason why I chose 2 different colored of dice. If I roll the number 1 on the red die, that's different than rolling the number 2 on the red die. So I'm going to count that as a separate instance of having rolling the number 2 and 1. And in other words, I can roll that in 2 different possible ways. All right. And so then I can pair up the number 2 with 2. I can pair up 2 with 3, and so on. And you can keep going. And just like I did before, you can sometimes just make a tree diagram with this. 2 goes with 1. And actually, I guess I should make that red, right? 1 and 2 and 3 and 4 and so on, right? I didn't finish the diagram. That's left up to you. So you could count them up all that way. And that seems pretty tedious. So is there another way? Is there a simpler way to do that? And the answer to that question is, yup, there sure is. It's called the multiplication principle. Principle. There we go, principle. And it's a counting technique that's very useful. When more than one thing is happening, it basically tells you how to count up all the possibilities. And let's say that I have 2 things, 2 events. And I'm going to label these events as event 1, and I have event 2. And I'm going to say, let's do this in numbers first, and then I'll kind of generalize it. Let's say that event 1 can happen in 5 ways. And event 2 can happen in 7 ways. And I want both of these events to happen maybe sequentially, maybe at the same time, whatever. I don't care. I just want both of them to happen, and I want to know what are the possible different pairings of these events, these 2 events that could happen. So I would take the 5 ways and the 7 ways. The multiplication principle tells me that I would multiply those 2 together, and I would get, obviously, 35 different ways that both of these events can happen together. You do not add them, you multiply them. So in general, it's usually done as variables, and instead of this 5 here, we would put something like A, and instead of the 7, I would put a B, and the total number of ways would simply be A times B. So instead of listing out all of these possibilities, which you still can do, of course, you could use the multiplication principle and go, well, how many different ways can I roll this die? How many different ways can I roll this die? And the multiplication principle would tell you that all you'd have to do is multiply those together. Once you're done, then you can throw those 2 things together in order to write your final probability.